Amazing photos of Earth from outer space. At number 5, we have a time-lapse of Venus, Earth, and Mars, captured from the NASA ESA Solar Orbiter. At number 4, this is a picture of a crescent-shaped Earth and Moon, the first of its kind ever taken by a spacecraft. Coming in at number 3 is an iconic picture that shows Earth rising out from beyond the lunar surface. The original picture showed Earth coming out from behind a vertical horizon with north at the top, but NASA felt the public would grasp it better if it showed the Earth from a horizontal point of view. At number 2, we have the blue marble. It may be one of the most widely distributed photographic images in existence. And number 1, the pale blue dot, a photo of planet Earth from a record distance of about 3.7 billion miles away. Thanks for watching.
The Kaguya moves toward the South Pole on the far side of the Moon. The blue Earth has appeared from the horizon. This is the Earthrise, as captured by the telephoto camera. The Sun is located right behind the Kaguya. The Sun's light is projected directly onto the Earth, which appears round like a full moon. In this footage, the Earth's southern hemisphere appears on top. This is a spectacular view of the beautiful planet we call home.
Image, Hakamada-san, look at it, it's just beautiful.
Yeah, beautiful and then very incredible pictures taken from our lander.
It is truly amazing how a privately funded spacecraft can capture the moon and the Earth like this and send the image back. Now, Hitachi-san, looking at this, I think this image also contains some scientific, very, very interesting speciality. Can you explain it a bit more?
Oh, yes, yeah. So this is the picture of the Earth lies on the moon, but most interestingly, as you can see, if you can take a very closer look at the Earth, so we see actually the shadow of the moon on the Earth. So you see that black spot there, that close to the Australia. So this is actually the shadow of the moon. So we took this picture during the solar eclipse. So it's really interesting to see this kind of the phenomena, not from the Earth, but from the lunar orbit. So this is very interesting and very exciting picture.
Thank you, Hitachi-san. And I believe we also have a video that I would like to share with you.
Wow.
Hakamada-san, doesn't this look amazing?
Well, this is real video.
Yes.
Not CG.
No.
It's amazing.
It's really hard to believe, but it looks amazing. So Hitachi-san, we see something in the lower part of the video. What is this?
Yes, I think this is a part of our lander. So this is a part that we call MLI, a multi-layer MLI, and we see the Plasma logo at on the right hand side. So it's really great. It's really amazing to see this, shadow and the bright part and the shadow part of the moon. So because there's no atmosphere on the moon, so we can clearly see the lunar surface, and this is really amazing video. I'm really amazed.
Thank you. And I believe we have one more image. Yet again, a video. Hakamada-san.
Well, another amazing, video. I cannot tell any word. Beautiful.
It really transcends words and it is just amazing. So
Hello, it's Scott Manley here. Now this is a video sequence constructed from the Himawari 8 satellite. The Himawari satellite is basically a weather satellite in geostationary orbit, and it provides some of the best high-resolution images of the Earth. However, when I post these images, there's regularly someone who has issues because they can't see the oblateness of the Earth. That is, where the radius of the Earth over the poles is smaller than the radius at the equator. Now, I have a way of actually illustrating this. I'm going to take two copies of the Earth and rotate one by 90 degrees. And then we're going to cut this in half. So this produces two different slices, one where the measurement is across the equator, the other is the measurement across the pole. And when we slide them together, well, you might be able to see the difference in the diameter right there, but to be 100% certain, of course, we can use the power of video editing to zoom all the way in close to the very edge. Now, this image is 11,000 pixels by 11,000 pixels, so there's plenty of room for the zoom, and you can indeed see there is a difference. This corresponds to about 21.36 kilometers. And in an HD image of the Earth, that is 3 pixels. So it's understandably hard to see if you're not specifically looking for it or measuring it. I'm Scott Manley. Fly safe.
Are likely the last you will ever see. Pluto orbits the Sun at a distance of 5.9 billion kilometers. It took New Horizons over 9 years to make it to Pluto, and a further 4 to get to the Kuiper Belt object known as Arrokoth. And given the intense NASA interest in Mars at the moment, it is unlikely they will invest in another mission to these far out objects anytime soon. Which is a shame, as there are some truly incredible sights to see on these planets. Their surfaces are covered in ices like nitrogen and methane, which have striking colour differences compared to the tar-like tholins that can also be found there. These reddish hydrocarbons travel in slurry-filled glacial rivers across the dwarf planet. The surface there gets as cold as minus 240 degrees Celsius, and low gravity lets massive water ice mountains stand 2 to 3 kilometers in height. Enjoy these images. Bear in mind, it took NASA nearly 50 years to send the first mission to Pluto. You may not live long enough to see the next images that are taken.
Across the asteroid belt. Finally, on December 30th, 2000, Cassini made its closest approach to Jupiter. It took about 26,000 images of the gas giant, its faint rings, and its moons during the 6-month flyby. Moreover, Cassini produced one of the most detailed global color Jovian portraits available to date. Furthermore, the image of the planet's volcanically active moon, Io, with Jupiter in the background, is a beautiful moment captured by Cassini. After a successful Jupiter flyby, general relativity. In 2003, mission scientists measured how radio waves sent from Earth to Cassini and received back again were deflected by the Sun. In addition, they measured how the round-trip time changed due to the motion of the Earth and the spacecraft. Eventually, the data provided by Cassini firmly supported Einstein's general theory of relativity and helped improve the existing accuracy to about 1 part in 51,000. After traveling for a league of astonishing observations of Saturn's system, the Cassini-Huygens mission discovered 7 new moons orbiting the ringed beauty. On June 11, 2004, Cassini flew by the moon, Phoebe. Images taken by the space probe revealed parts of the heavily cratered surface of Phoebe shining brightly. The photos gave an idea that a large amount of water ice probably exists under its immediate surface. Finally, after 7 years of journey, Cassini reached Saturn, achieving its required orbit on July 1, 2004. This made Cassini the first spacecraft to ever orbit Saturn. A day after its orbit insertion, Cassini had its first flyby of Saturn's largest moon, Titan. During this phase, the probe collected numerous pictures of Titan's lakes. And on December 25, 2004, Cassini released the Huygens probe to study Titan.